Well, I was pretty surprised when I opened the post yesterday and there were two Uniden based sets. This one's an Audioline. I think the other's an Audioline as well. These belong to an end user. We don't normally do end users, but during this lockdown we're doing one or two to help out because, you know, obviously shops are shut and they want the radios, so we will do it. We don't tread on the toes of shops. That's why we only deal normally with the trade. Anyway, original mic. I haven't read the notes, but what he has now said is after that recap experiment, which I was really sceptical about because I don't believe in doing that. He wants me to recap this, which we will. So I may as well take all the lids off because they're going to have to come off anyway. And Mr. Chippy wants me to do a recap using ordinary capacitors rather than those high quality ones to see whether it makes an actual difference, because I think what we've ended up doing is we've made the radio better than it ever was, so because it exceeds all the manual's parameters by a long way. It was supposed to be a York 863 today, but we're set up for Uniden, so we may as well do this customer's two Unidens, and it makes it a bit easier for us while I've got the manuals out and I can actually remember what we're doing, because I have a memory like a sieve, and always have had. And I have to unsolder the speakers in these. So you've got those two which are going to have to be changed anyway, and then we're finding the audio ones getting a bit problematic, so nowadays we're needing to change 4 anyway, so we may as well change the other 18. I'm going to power it up and we'll see what it does as it's come. And then we'll know whether we've fixed it worse or not. Okay, so it's on channel 13, unlucky for some. So the fact the display's lit up means that that capacitor is still working. That 220 just there. But they do need changing anyway. So let's have a look what it's doing. I'll put picture in picture on and then we'll look at the power meter. So it's transmitting at 3.1 watts. Go to the 3 watt scale, it's a good 3 watts. Deviation, while, oops, we're not tuned in for some reason. While, well, about 1.8, so it's a bit quiet. And now we'll look at receive sensitivity. Go over to the Synad meter. So that's 100 microvolts on the radio. And if we plug the speaker in, we might actually hear that. And S9 is not far off S9. So let's look at the Synad. So it's Audioline. .340. So before TX 3.1 watt, deviation 1.8 kilohertz, RX 20 dB, 12 dB, 10 dB. So we're looking at, right, scale 0.52 to 12. So that's exactly on the ball. I think it's supposed to be 0.5. So it's just minutely out. And of course that we haven't tuned it. Decibels, 0.37 microvolts, and 20 decibels, there's clearly some noise there. It's not. It's 4.4 microvolts. So that's where we are. Right, so I'll get on and change all those capacitors, all 22. Okay, so we'll come back to it. I've taken the 22 capacitors out and replaced them with the Nichicon ones, all except one which isn't a stock item, so we put an expensive German one in instead. So the non-Nichicon capacitor is that one there, which is 0.22 microfarads. So I've run over that with isopropyl alcohol, so hopefully it'll be nice and clean underneath. Okay, so now for the tune-up, it lights up still, so that's a good start. There's the microphone. Still receiving. Okay, let's look at where we are with transmit, and we'll get the meter and we'll check the VCO. We didn't do this before because it was pointless. It doesn't alter with the changing capacitors. Now, because I did the other one yesterday, despite my rubbish mind, I've remembered that these radios have a floating chassis. If I just connect that up to negative, to my negative prod, and our test point is there. So we want channel 40, and we want 3.5 volts. We've got what? 3.38. I'll come back to that. We'll start the tune-up because I haven't got the soldering iron on. I need that to do the coil. So camera 1. You know, I've been faffing around so long, I bet the soldering iron's warm enough to do that. Right, we're in. So key up the mic, put the probe on there, and bring that up to 3.5 on channel 40. If you don't check the VCO, you can find channels missing. That's more than good enough. Now we'll go to channel 1. Make sure it's at least 1.8. That seems to me to be in lock. get no end of queries and repairs as well, where people find that lower channels or upper channels are missing if they don't drop the soldering irons on the floor. Right, we'll just deal with that. So looking at the meter, it was 3.1 watts before, it's now about 3.2. So we'll just run through these. Oh, wants to be on channel 20. Let's look again. Actually about 3.3, so it's come up a fraction. You know, I've only done one of these yesterday. I still can't remember whether that's receive or whether it's transmit. So we'll twiddle it now. It is transmit. So we're now about 3.4. So we'll just peak that one. I'll put the spectrum analyzer on ready as well. It's alright. And hopefully we get it up to the 4 watts with this one. So let's see what it will go to. It goes to about 4.1. Remember, this is a selective test set. Oh, but I'll tell you what I bought. I bought one of the Zitagi power meters. So we'll look at that. We'll look at that pretty shortly. In fact, I'll tell you what. I'll pause the video and we'll get it now. There we go. A Zitagi model 203W. 45 quid. I put a dummy load in the back. Put a VNC adapter in the back. And I spent my nectar points on it, or whatever they're called, rather than waste my own money. So, just to be clear, 4 watts, there's 5, there's 4. Let's see what Mr. Zitagi says. So we're on the 10 watt scale. Here goes. It's what, 5.2? Would you agree? I always say, you know, when I tune these radios and they say 3.5 watts, they're going to be about 4.5, 5 Zitagi watts. So now, I'll tell you what we're going to do. We're going to plug the aerial in. Well, you never read power with an aerial. It doesn't work like that. And I see people showing radios doing stupid power levels on YouTube, and they've got an aerial connected. So I've now got the aerial connected. That's the one we talked to Mr. Chippy on. So we'll now go into SWR mode. We'll key it up. And there's our set point. And as you can see, we've got about 1.5, just over 1.5. Okay? So now we'll go over to watts. Oh, look at that. It's doing 6 watts. Well, of course it isn't. We know it's doing exactly 4. I'm going to get this out every job I do, just for the laugh. We're going to have real watts and Zitagi watts. I've done a video on comparing different meters before, and that can always be looked back on. I've compared quite a few different meters. Right, I digress. So we're now back into the test set, and it's doing 4 watts. So the best thing to do is to set the TX meter. So it needs to be in the centre of the red zone. And get the tool in there. So it was just a bit showing a bit high. So right in the centre of the red zone. Then on the low power setting, so we'll switch the radio to low power. That should be 0.4 of a watt. It's 0.5. So that's neither here nor there. But we'll just get it right. It's not like it's a legal requirement anymore, but it's a very useful feature, and I miss it on sets not so equipped. So that's done that. Now we'll look at that deviation, because it was 1.8 before, so probably what's just popping up. So see what that's like with the whistle to voila, spot on. 2.2 to 2.5. So that needs to come up a bit, and that's fair enough. So I'm going to look at it on the spectrum analyzer. We'll just loosely couple that. So we'll put the camera onto that. And press auto. So there we have our 27 meg signal. Oh no, that's our 55 meg signal. That's not good. Right, so what we'll do, we'll put in 27, frequency 27, 79125. Right, so we have a situation, once again, I've just moved that camera, it's not exactly centred, where we've got more on 54 megs than we have on 27. So there's our 27 79125 signal, and there's our 55 meg signal, which is far from ideal. So we better have a play with these coils and see whether we can improve matters. Because it's not a set that's being played with. I mean, that one's out of alignment. We'll drop the power down and do it the other way. So let's see what we can do. Right, so we've got 4 watts. Let's see what we've got. We need to see what this is actually doing. So we need to measure that. we just inspect there at 72, minus 72 dBm. So only just inspect. As you can see, it was actually, there was more power going out on 54 megs than there was on 27. So now we'll go back to the meter, the normal meter, and when I key up, I've still got 4 watts. Good. That's why it's so easy to end up with messing up the PA. So it was a matter of actually adjusting them all for the lowest second harmonic, but we still ended up with 4 watts. So that's a great outcome. There we go, 4 watts. So that's something we'll need to do on the Uniden 100 we did the other day, because I didn't have time to do any of the finishing off things like that, or the squelch. Good. So what shall we do next? We'll look at the receive. So the first thing we need to do is to go over to, oh, I'll tell you what, just for the laugh, we'll look at how the frequency is. Remember, it's not adjustable on these, but it needs to be in spec. Oh, that's, wow, 2779131. It should be 79125. That's fantastic. Now that's one of the best examples I've seen recently. Right, so we'll now move over to the oscilloscope, and we're going to put S9 on the signal generator. And let's have a look if we can peak that with the coil. There. Yes, we've got a fraction more out of that. That should improve clarity. So while we've got S9 on the radio, we may as well do the S meter. And the S meter is pretty well bang on S9, but we could just trim it a fraction. It says it's RT1. Just needs to back off an absolute fraction. So there we are. So that's done. So now we're going over to the cyanide meter. We want about 4 decibels on there as usual, and we need to just run through the front end. Oh, without tuning, let's see what our 12 decibel figure is before I touch the tuning. So for 12 decibels, the radio is now doing 0.1, yeah, no, 1.7, 0.17 of a microvolt. So that's come down immensely without tuning. So, I'll tell you what we'll do, and that's look for the pen. So, before, caps, retune. So we've got 0.567, 0.82 to be honest. We do the 10. 0.15. No, it can't be. It's 0.155. I've read that wrongly. It's 0.182. Let's go back. Yeah, 0.182. And then 20 dB, change scales, we've brought down to 0.415. So we'll do the tune. So there we are with 4 dB. Put a bit more signal on for this one. I think that's as good as we're going to get. So now we'll look at those again and see if there's any change now. So we'll start with the 12 because that's the industry standard. Look, what if I made it worse? So it's now 0.185. So that's worse. Naught 0.154, so that's tiny better. See whether we've improved that one. Naught 0.412. So the tuning is actually not really made any difference. We've got better on the 20 dB, less noise. The absolute sensitivity maximum, that marginal bit better. And the 12 dB, it's dropped slightly. So it's the same, isn't it? So the big thing is changing those capacitors rather than the retune. So look at the difference: 4.4 to 0.412, 0.5, which the manual says 0.5. It says better than 0.5, and it was just above that. But I mean, you could argue how you read the instruments, can't you? You know, there's a bit of tolerance there. 182, 185, and then 10 dB, 0.37, and we brought it down to 0.154. So it really is sensitive. So sets which I've always thought were not sensitive, this has improved, and I was very sceptical because I'm not a believer in doing this kind of thing. It's a bit popularist. Okay, so we've done that. We better set the squelch up. So I'll put the controls on. I'll put the camera on the signal generator. So we're parked at 0.3 of a microvolt. So we'll set the squelch to full. There we go, it's squelch to full. Switch the signal generator on. I want it to come on at 100 microvolts. There's 10, there's 30, there's 100. I want it to be there and it isn't there. 300, 1 millivolt, then it comes in at 3, which is ridiculous. So I need to back this off the squelch until we can hear. It's that one. 30 microvolts it's off, 100 microvolts it's on. That's where I want it. So now we'll check it at the sensitive end. So we'll turn the squelch down, set it to threshold, switch the signal generator on, and then let's see where it disappears. So we're losing it at what, 0.25 of a microvolt. It's coming in at 0.31, off at 2.55, on at 0.31. So it's absolutely splendid, that. Well, do you know what? I think we've covered everything there. It's got a tone control. We'll just check that works. So that was with the tone in the low position is how we got those readings. And that's how we tested it in the beginning as well. I should have proved that to you. Right, well, I think we can put the radio back together and shove it on the aerial. Okay, so let's see what we can pick up now. 1 on a Roger, 19 a Roger. Okay, so we've got a nice radio. And it's immaculate and it's even in its box, so I'm sure you'll be very pleased with that. So that's another one improved. We don't get many audio lines, and having done that Uniden the other day, that's got public address, I notice, whereas this hasn't. Not that that matters, but it helps our fault finding when there's an audio problem. So there you have it, the Audioline PT340 from 1981. Thank you for watching.